Welcome back, everyone. In this lesson, we are going to take a look at another practical application of using Python and Python libraries to, do some data analysis. This one is going to be dealing with climate change. I have some spreadsheets here. I have a global greenhouse gas XLS, which you can see it's got these countries alphabetically listed, and then the amount of emission that they had from 1970 all the way to 2012. And I have another global temp.csv, which, as you can see, has the global temperatures listed from 1970. And I have one that is for the various states in the United States. And this is the amount of carbon dioxide emissions from 2000 to 2014. So we want to do some analysis of this stuff, and we are going to be working with a new library, which is Plotly, and another one called Chart Studio, which if you don't have installed, you need to do pip install to install them. So pip install Plotly, pip install Chart Studio. We're also going to need pandas, matplotlib, pyplot. So go ahead and once you have this installed, as you can see, mine, the requirements are already satisfied. We've already installed them. You need to do a shift enter here to import these libraries and then get going. Now, Chart Studio and Plotly, they do have their own API. So if you open up an account, you can use your account name and your key, your API key here. But this is usually optional. I mean, I've never had to sign in to use them, so that's why I commented it out. But you can certainly sign in. The benefit of signing in is you can save your stuff to their website, so which is not a problem for me right now. So I'm going to call this offline init notebook mode, which means that I'm not interested in working with them online. So I'm just going to do that. And then I'm going to import my data. The data does come from NOAA, as you can see. So you can download the latest versions, if you like, from NOAA. First, the global temp.csv. My index column is column 0, and the header is header 0, which kind of makes sense because if I open up this once again, you can see that I want the index column to be this and the header column to be that. So that's 0 and 0 as far as Python is concerned. Then for global gas, I'm going to read the global greenhouse gas.xls, and this one is a little bit different. The index column is 0, but the header is 3. And I'll also want to fill the non-existent values with 0 in this case when I'm reading it in. So if we take a look at this, does that make any sense? Well, let's go all the way to the top. So I can see that the index column being 0 does make sense. That's where I have the countries, but you can see that the header is 3. So 0, 1, 2, 3, and that makes sense. That's where I have the header stuff. And I also indicate that I want to, when I read this in, as you can see outside of that, anything that is not a number, so for instance, a bunch of stuff that are non-existent here, I'm going to just replace those with 0, although I'm not interested in 1969 anyhow. All right, so having done that, let's go ahead and take a look at the first 5, which is a default. So I can see 1970, that's the global temperature, and it shows the value and the anomalies, and the global gas data frame that we've created is going to show you some of these countries: Aruba, Afghanistan, Angola, Albania. And it shows nothing, of course, for the 1960s. They've been replaced by zeros as we requested. And this goes ... and then we see some of the 2000s. All right, let's create a list. It's a columns variable calls. It's an empty list. And for this loop variable I, we're going to range from 1970 to 2013. Let me write this 2012 plus 1, because remember the last index is not included in the for loop, but we want 2012 to be included. And I'm going to append the string of I into that. So if I do this, you can see that I have basically 1970 through 2012, which is what I'm interested in. So this is a list. Excuse me. Now what I want to do is to reformat my global gas data frame to get rid of those 1960s. So all I'm interested in is the columns to the length of these columns. So this is what I'm interested in, is 1970 to 2012. So I do that, and if I look at the head now, you can see that those 1960s are now gone. They're history at this point, which is what I had in mind. So this is part of sort of the data cleaning, data management, if you will. All right, let's take a look at the states. With the states, as you recall, it was from 2010, I think it was, or 2000, I'm sorry, to 2014. So we're going to read this state carbon dioxide XLSX, and the header is 4. So you have to go 0, 1, 2, 3, 4. That's where it's located. Once I have that read, I'm going to drop the percent and the absolute columns. That's why you say axis equals 1, as you recall, because this means to drop the columns and not the rows. If you don't put axis equals 1, it assumes you're dealing with rows. Just for the sake of clarity, let me just do this. And I'm going to insert cells above this. And let's take a look at state gas dot head, so we have an idea. So you can see that I have the states, etc. I've got this percent and absolute, which I really don't want. So if I do it this way, if I read this again, recreate it and drop those, and axis 1 means columns, and also remove all the not numbers, and then take a look at this again, you can see that those are gone. We have a nice clean data set to work with. Okay. So I already did this. I can basically get rid of this one. Get rid of that. So for a given year, let's determine the top 10 emitters. So I'm going to create a function top 10, pass to it the year, and assuming that they don't specify a number, we're going to give them the 10 the 10 emitters. If they specify 20 or 5 or 1, we can give them that. I have a df variable for data frame, and this is going to be my global gas that we created for that particular year. Now, I do want to, and this is the area that you guys need to experiment with, I can always call global gas and pass to it a year that I want. So for instance, I can say 1972 and take a look at it. And it gives you these countries. As you can see, it's dot, 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 goes all the way to the end. So this is what we're doing here. And I'm going to have top B df.sort values ascending equals false, which means that the lower, it's going to sort from the bottom, in reverse order. So it's going to be top to bottom, if you will. I'm going to reset the index. I'm going to put the default index on these things, and I'm going to get the head total. Just to get an idea of what the heck's going on here, let me insert some cells here, and let's take a look at that. So I have df. In fact, I'll copy and paste it here. So I have this, and I'm going to put a year. Let's say I put 1970. And I'll take a look at df. Okay, so it gives me that. Good. Let me insert another cell here, and let's see what the next line is doing. We're calling df.sort values ascending equals false and assigning that to top. Well, let's do that. And take a look at top. So there is my top countries. As you can see, United States in 1970s was the greatest emitter. Now what we're doing is we're resetting the index. Well, let's go ahead and reset the index. And let's say we want the top 10. So that's the total. So I'm going to say 10 here. And then take a look at top. And you can see that we got the default index back, 0, etc. But what we really want is the index to be equal to index plus 1. So let's go ahead and get that. And let me insert some cell above here. And let's take a look at top again. And what this does, it makes it be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the process. And then you say, well, let me turn that into a function. And all I'm going to do is return top. So by doing this, I can look at now top 10 of 1970. And I get the same exact one that I had up here that I showed you step by step. Let's take a look at top 10 in 2010. We can see in 1970, United States was number 1. Russian Federation or Soviet Union at the time was number 2. China was number 3. 2010, things have changed. As you can see, China is an order of magnitude larger than the United States in emitting dirty stuff. Brazil, India, Russian Federation is way down here now. For one thing, it is no longer as big as it used to be. It's split up into multiple countries, as you can see. Interestingly enough, if you look at, say, a country like Germany, 1.28 times 10 to the 6th power, and then take a look over here, Germany went down slightly. So they're actually cleaner now with larger population than they were in 1970. So the opposite can happen too. That's the point. Japan actually went up slightly, not a whole lot, but they went up slightly, as you can see. And then you have some countries that didn't exist in these top 10. So you have the Congo, Democratic Republic of Congo, which wasn't even in the top 10 because of the tremendous mining that's going on. They've made it up here, as you can see. India is climbing up because of their industrialization, of course. And then we have Canada and Australia, despite they are industrialized, but despite their small populations. I think Canada has 33 million people. Australia is like 24, 25 million people. As you can see, they emit quite a bit. They're in the top 10. So now I'm going to take a look at this again, just for the sake of one more time seeing it. And this is what I demonstrated to you guys up there. What I want to do is I want to take a look at, if I have this top 10, if I call top 10 colon, what do I get here? Let's see that. Well, that's going to give me a top 10 colon. That's going to give me all the other countries beyond the top 10, as you can see. But what if I call just sum on those? If I call the sum on those, that's going to give me the country name is basically it's just 1970. It gives me the total sum for all these countries. You can see they've been stringed together: France, Ukraine, Canada, etc. If I pick, so you can see this is really, I could slice this. This is 0, this is 1. If I get position 1, which is, this is 1970, this is 1, so this is 0, this is 1, I get just that total for all the other countries. So this is a clever way of getting the total emission for all the other countries. And in this case, this one was for 1970 because I picked 1970 for the initial data frame. So given a year, I can make a pie chart of the top 10 emitters. So let's create a pie plot, very similar to what we did up above, global gas for the year that is past. Sort the values in reverse order, reset the index, add 1 to the index, and this is the others variable, which I just did up here. So top 10, and we're going to call sum 1, so that's going to give you this sum and assign it to others. So my top variable, I'm going to set it be equal to top 0 to 10. So this is going to include the top 10 countries, 0 through 9, which is, or 1 through 10, if you will. And then I'm going to create a 10th location. This is lock 11, if you will. And I'm going to call, instead of having a country name, such as France or Germany or United States, I'm going to label it all other countries and assign it that others total, which is this for whatever year it was. Now I can call the plot method and call the pie method. And pie, and remember the default is a line. You can have a bar chart, you can have a pie chart, which we haven't seen before, but here's a pie. And then you can go and take a look at Matplotlib's pie method and what it is. First, subplots is equal to true, so it allows you to create these, cheese slices. That's what it means. Auto percent is set to 0.1f, so this is a floating point. I'm expecting to have up to 1 decimal place after the decimal point, and whatever is before that is okay. My font size, figure size is going to be square, being a pie. That kind of makes sense. I don't want legends. I want the labels to be the top country name. That's going to be my labels. I don't want shadow for the pie. And this exploit, you have to play with it. This basically creates it takes a piece of the pie out. Depending on which one you want to take out, you can play with these various values, which are typically between 0 and 1. But I just wanted the top one to be pulled out, so that's what I'm pulling out. The rest of them are not being pulled out. and start the angle rotation at 90. Again, this is something you can play with and until you get the result that you want. So I'm going to call 2010 pyplot with 2010, and I'm going to call the matplotlib plot method and show it. Let's take a look at this. So here is the explode, as you can see, and there is China, and there is the other countries, and this is the all other countries label that we created over here. And that's basically showing that China was the biggest emitter. Almost a quarter of all emissions were in China in 2010. Let's take a look at it in 1970. We can see that at that time, the United States had 1/5 of all the emissions, and China was small, 6.9. Compare that to today at 23.4. So if you look at it in those terms, it's grown by fourfold, basically, their emission that they have. And then you can look at some of the other countries as a comparison. Let's take a look at the global temperatures over time. Actually, what I will do is I will end this video right here, and I'll make a second video to go over the rest of this. So as always, thank you for being a great audience. I'll see you in the next video after this one, so you can have a break in the middle.